In this video, we'll dive into the cutoff job in SolidCAM. The cutoff job in SolidCAM is used when you want to perform a parting on your machine. So here, we've done all the necessary preparations on the main spindle, and we've also pulled apart. So you can see here in this MCO, if you look from the front, our lower turret is parked in the correct position, also the upper turret, and we are performing this pulling. And now we can do a parting between two spindles here. So let's go and close this and add one cutoff job. For our geometry, we will be selecting only this line here, since here is the line where we want to do our parting. Confirm the chain, confirm the geometry, and we'll go to modify geometry just to make sure that our geometry is extended up to the stock. We can confirm this. For our tool, we will be selecting our groove tool for the cutoff. So let's go and select this tool number 2. Confirm. In the levels page, we will leave the 2 millimeters of our safety distance and we'll move on to the technology. Technology can either be with the modes, it can be long external and long internal mode. For this purpose, we are using an external mode since we are approaching from external of the part. And now at this point, we can go and just calculate and see the toolpath that we've got. This is the toolpath. So here we define a side. Is the tool from the left side of the geometry, maybe on the middle? If we recalculate, you will see it moving, or maybe it is on the right side of the geometry. So you will not see it, it will be exactly on the line. If we go, this is clearly a left side of our geometry, and we can calculate. We can have a constant step down, or it can be a single pass right down to the center of the part. We'll be using a constant one with the 2 millimeters of step down. For the release distance, between each of the step downs, we can say it will be 0.2 millimeters. If we want to retract at the end from the part in some side, let's go, for example, here, we can go 1 millimeter and calculate like this. But we will not be using this since we are using only parting technology, so we will go and do our job only to the center of the part. For the offsets, for a back spindle, you can leave the offset, for example, 0.2 millimeters and recalculate this. So it means that if we go and simulate now this job and play, we will have 0.2 millimeters here left stock for the machining of the face turning on the back spindle. Let's go now and close this. Here we have options to define a corner. For example, our corner can be chamfered. Is it the left side or the right side that you want to chamfer? We want to chamfer the stock that we leave in the main spindle. So we will be using a left side, not the right side. And here we can say, for example, angle will be 30 degrees and I will use my distance to be 2 millimeters for my Z. If we recalculate this job now, you can see that it will cut out this chamfer here on the stock. And if we simulate the job, it will perform it immediately here. Of course, we can do on both sides here and select both and recalculate. So what will happen now, if we simulate the job, we'll have both sides chamfered. Let's go now and close this. Same thing we can do with the fillet option. We can do a fillet of 2 millimeters radius and recalculate this. And if we simulate, we will have a fillet here. Let's go and close this now. For our cycle, we can either use it or not. This is depending on the machine and it will be covered in a separate video. For a link, we will be using from the right safety corner up to the, again, right safety corner. And in the technology now, we can say we want only left side to be chamfered and recalculate. So this will be our cutoff job. And now if we simulate it, you can see that the stock splitting here will automatically be performed, and we will be left only with this part and this portion of our part. Thanks for watching this video, and see you in the next one.